Hello, my name is Robert Cook. I'm with JTech Institute, and today we are showing how to do diagnosis and maintenance on battery systems. One of the things we must consider before we get started is protective gear and tools. We must have the proper protective gear when doing the job. This one mainly is worried about eye pro, which you should have at all times in the shop. And the other is your tools and the positioning in which you put them down when you're using them. Making sure that we do not make connections between positive and negative lines, allowing current to flow, causing the possibility of damage, destruction, and injury. The next thing we want to do is go ahead and determine what our battery group type and how to get our battery capacity or our cold cranking units for the vehicle. One of the first places you like to look is a website like ProDemand. You would go to our common specs and procs section after entering all our pertinent information for our vehicle. Today we're using a 2000 Nissan Sentra. And we would look here on the battery area, but unfortunately, in our particular situation today, our battery section says NA. So we're going to look another place. We're going to go to our Napa Pro link as if we were trying to purchase one. We enter all our pertinent information using our VIN. We do a search for battery, and we'll pull that up. Once that loads, we can look here for its particular offerings. And you'll notice that there's many different settings, but confirming with the battery we have in the system, it is a 35 BCI, and our cold cranking amps are 640, which the very first option on our video reflects that there. The first form of battery diagnosis we're going to perform at this time is going to be an open voltage test with a voltmeter. We're going to go ahead and turn on our voltmeter, which we've done ahead of time. Test to make sure that it's working correctly. Then we're going to connect our positive lead to our positive terminal and our negative lead to our negative terminal. And we're going to read it with the vehicle off for at least 10 to 15 minutes prior to testing. Our vehicle's been off for more than an hour. We see that it's reading at 12.27 as we've been performing multiple tests, and multiple students have been doing so at this time, so our voltage is a little bit low, but this is still reading within normal range. So our test is successful. At this time I want to demonstrate how to diagnose a maintenance type battery using specific gravity battery test. First thing we're going to do is we're going to make sure we have our battery tester. We're going to use our maintenance type battery. We're going to remove these covers, the maintenance covers, which we've already pre-done for this demonstration, and place them to the side. We're going to take the battery tester and dip it into each of the cells, or 6 cells in these batteries, to test the specific gravity, which is shown here on the side and will be indicated by a dial, of each cell's battery compartment. I dip it inside, bring the fluid in. It's going to show that we are at 1300 specific gravity, which means this cell is functioning properly. Each compartment should be within 50 units of specific gravity and no different. Any more than that is an indication of cell malfunction. The battery should be either attempted to be recalibrated with changing the acidity of the cell or replace the battery. Okay. For this on each cell, moving on to the next side. Again, so far each cell has performed at 1300. This battery is looking good. Okay, and last one. And here we are. We turn all the cell fluid back into each cell, and we finish that test. At this time, we're going to perform a conductance test using an automatic conductance tester. We're going to place our red lead on the positive first, and then our black lead on the negative. Okay, we're going to let it boot up. It's reading a voltmeter of 12.28 volts directly from the battery. Then we're going to use it as in vehicle, because that's where the battery is located. You're going to select the post type, which this is a top post type. And it is an automotive, but it does multiple uses. It is a regular flooded, battery, but there is also a spot for the flat plate and the spiral type. Battery standard is cold cranking amps, so we select that there. Rating of 600 is correct. And the meter does say that we have a good battery, but it does need a recharge, so we will work on that next. At this time, we're going to conduct a battery load test. In this process, we're only going to make a test for no more than 10 seconds at a time. After we earlier established our cold cranking amps, which we have noticed is 600, when we're conducting this test, our load should go no higher than 300. However, that's for industry standard. For our training purposes today, it will go no higher than 200. We've already made sure that our positive and negative leads are attached, and we are now going to attach our inductive ammeter on the cord. After we turn it on to 200, and we're going to zero it. Place it on either cord, does not matter which one, and we'll conduct our test. We'll see that we're currently set at 12 amps. We want to put the load at 200, so we will twist our dial until we see 200 amps. Load. And we don't want it to go below 9.6. That is our industry standard. This is getting close, but for our testing purposes, that is okay. At this time, we're going to go ahead and demonstrate a fast charger. We already have it hooked up. Under normal circumstances, the power would be off. You'd connect your red terminal first, and then your negative terminal, and then turn on the machine. Here you can adjust the settings, select whatever you need, toggle to the different settings that you want. Right now we are set on our auto charge, and all we'll have to do is hit our start button, and the slow charger will do the work for you. The big difference between this and a trickle charger is a trickle charger charges it slowly over a lower amperage over a longer period of time to keep the battery life a little bit higher. This is a fast charger, used to get us back to functionality if we have the simple issue of an alternator not working or a dome light or something left on overnight. Okay, at this point we're going to go ahead and test for parasitic draw. We're going to set up our digital multimeter to read milliamps, and we're going to test to see if there's a unwanted draw on the battery power when the power is off. We've already got our negative lead set up onto our negative attachment. We're going to set our positive lead directly on to the negative terminal. This will keep things like the radio settings and others still in place. We're going to lift this terminal up to where they're no longer touching, and our digital multimeter is reading 1.93 amps, and our rule of thumb industry standard is 50 milliamps, so we're well below that limit, so we know that we do not have a parasitic draw at this time.